Hello everyone, my name is Christina and I will be talking to you today about the most important topics we have covered during the Embedded System Internship offered by Emertxe. This internship was a great opportunity and gave me the chance of learning C programming language foundations and how to program and develop a component-based embedded device. The project presented in this video is about developing a microcontroller for a microwave oven device. Before moving to the project simulator, I'm going to make a little journey in the C programming language foundations and reveal why it's being used in embedded system development. C was created by Dennis Ritchie at the Bell Laboratories in 1972. It's a very popular language despite being old. It's simple and flexible programming language that is widely used in various applications. C is a general purpose language. It's a free formatted language and it's preferred because it runs faster and takes less space than other programs. Efficiency and portability are the most important considerations. Library facilities also plays an important role. As basic data types, there are two categories that we can break this into. We have integral data types, and this can be either char used to store a character or int used to store a value of numeric type. The second category we'll have is floating point data types. And this can be either float used to define numeric values with floating decimal points or double similar to floating data type except it provides up to 15 digits of precision and occupies 8 bytes of memory. C has 5 data type modifiers. We have short, long, long, signed, and unsigned. The difference between them is that a short int is stored within 2 bytes of memory, a long int is stored within 4 or 8 bytes of memory, and a long one is stored within 8 or 16 bytes of memory. A signed int, it can represent both negative and positive numbers and stores 4 bytes of memory, while an unsigned int can store only positive numbers and occupies 2 bytes of memory. We have the following types of conditional statements in C. Conditional construct with single iteration. And these are if statement, if else statement, if else if statement, nested if, and a switch case. In regards to the if statement, if condition is true, we'll execute the statement from if block. If condition is false, will not enter into the loop and will print the statement after the if block. If else statement, if condition is satisfied, we'll execute the statement from if block. If condition is false, we'll execute the else statement. If else if statement, if condition is true, we'll execute the statement from if block. If condition is false, we'll check for the else if condition. If else if condition is false, we'll check for the else condition. Now let's talk about the switch statement. The switch case in C is an alternative to the if-else-if ladder statement, which allows us to execute multiple operations for the different possible values of a single variable called the switch variable. The second category we have is a conditional construct with multi-iterations, and these are for, while, and do while. For allows to loop through a block of code a specific number of times, and if condition is true, the statement will be executed. If condition is false, will come out of the loop. While refers to the entry control loop, because you cannot enter into while until condition is not true. If condition is true, we'll execute the statement from while and then we'll check again condition. Do while, also called as exit control loop, enters into the loop without any condition and comes out of the loop if the condition is false. Operators in C. We have arithmetic operators like addition, subtraction, multiplication, division operator, and modulo operator. We also have relational operators, and these are less than, greater than, less than or equal, greater than or equal, equals to, and not equal. Logical operators, and are not. In C, we have pre and post increment operators. The increment operator increases the value of variable by 1. When we apply the increment operator, the change is happening immediately. On the other hand, when we apply the post increment operator, change of the value happens for the next segment. Next category we have is a bitwise operator. These are bitwise AND, bitwise OR, bitwise XOR, bitwise complement, bitwise left shift, and bitwise right shift. What is specific to these operators is that operations are not applied directly to the values, are applied to the bits of a given number. The bitwise operators are used to perform bit-level operations on the operands. The operators are first converted to bit level and then the calculation is performed on the operands. We also have assignment operators and other operators as ternary operator. A ternary operator takes 3 operands or variables instead of 2. It is a way to shorten the simple if-else code of the block. Another important topic in C is about arrays. An array is a collection of data of same data type. First element will be with the lowest address and the last element will have the highest address. Each element in the array is accessed by index. Strings. A string is a continuous sequence of characters, set of things tied or threaded together on a thin cord. End of the string is marked with a special character called a NUR character. NUR character is implicit in strings enclosed with double quotes. Memory will be allocated also for NUR character. The difference between a character array and a string is that string is terminated with a unique character. Pointers. Pointers are used in C in order to store the address of a variable or a memory location. We can access and manipulate the data stored in that memory location using pointers. As the pointers store the memory addresses, their size is independent of the type of data they are pointing to. So for a 32 bits operating system, pointers will have 4 bytes of memory. In case of 64 bits operating system, pointers will have 8 bytes of memory. We can add an net sign to the variable in order to store the address in a pointer, and we can add an asterisk to the pointer to extract the value of variable it is pointing to. Functions. A function is a set of instructions which are set to perform a specific task. Functions can be stored in a library and reused. When some specific code is to be used more than once at different places, functions avoid repetition of the code. A function can have 3 parameters: input, operation, and output. For every function we call, there will be a stack that is created. After the function is executed, the stack will be destroyed. In C, we have 2 types of parameter passing. First category we have is a pass by value method. This copies the actual value of an argument into the formal parameter of the function. In this case, changes made to the parameter inside the function has no effect to the actual argument. We also have a pass by reference method. This method copies the address of an argument into the formal parameter. Inside the function, the address is used to access the actual argument used in the call. This means that changes made to the parameter affect the argument. As a built-in function used in C, the most important are strlen. This will show the length of the string. We have to pass the address of the string where it is found. It gives length of the string, excluding the NUR character. strcmp. This function compares two strings. We pass the address of the string as an argument and returns the value. If the value is less than 0, then string 1 is lower than string 2. If the value returned is greater than 0, then string 1 is higher than string 2. And if the value returned is 0, then string 1 is equal with string 2. Another function we have is strcpy. This function is used to copy two strings. First argument we pass it as a destination, second argument we pass it as a source. str. This searches for a substring inside of a main string. If substring exists, we return an address. If not, we return no. strchr. This function is used to search for a character inside of a string. If the character is found, we return the address. If not, we return no. strcat. This function is used for string concatenation. Further, I will be going to provide some insight in regards to the embedded systems. An embedded system is a combination of hardware and software which is intended to do a specific task. As examples of embedded systems, we have microwave oven, washing machine, fridge, router, and airplane. There are four major types of embedded systems. We have standalone, and this can be either slave, will follow the actions as it is, will not do actions on their own. As examples, we have microwave oven, semi-automated washing machine, and independent embedded systems take necessary action by their own and are having intelligent parts integrated. As example, we have a fully automated washing machine. Another category we have is real-time embedded systems. If the system is able to take the action in a given amount of time. As example, we have an airbag. Networked embedded systems. These are connected over the network, and as example, we have a ATM machine, router, home security system. The last category of embedded system we have is a mobile embedded systems. As examples, we have a car. An embedded system has the following main components. It has the microcontroller, a system on chip, or can also have a microprocessor. It has a memory, actuators, and these are used to take actions to the analog signal, sensors, in this case output will be analog. It also has a digital to analog converter, and this is used to convert the digital signal into an analog output signal. An analog to digital converter that is used to convert to analog signal to digital signal. It also has human interfaces. As examples, we have LEDs, LCD, and LCDs, and diagnostic ports that will check if everything is working fine or not. Next, I'm going to talk about a microcontroller. A microcontroller is an integrated circuit which is capable of being programmed to perform a specific task. Unlike microprocessor, a microcontroller has all components integrated in a single chip. So it has time, random access memory, read-only memory, peripherals, ports, and CPU. It's less flexible and requires less design complexity. For our project, we have used the XC8 compiler, MPLAB-X integrated development, PixLab simulator board, and as a microcontroller we have PIC16F877A. This microcontroller, PIC16F877A, supports three timers, time 0, time 1, and timer 2. Time 0 is an 8-bit time. It supports two modes, time and counter. It's readable and writable. Timer 1 is the same with timer 0, the difference is in the resolution. Timer 1 is 16 bits. Timer 2 is an 8-bit timer with prescaler and postscaler. The timer 2 register is readable and writable and it's cleared on any device reset. So this is our PixLab architecture that will show an overview about how microcontroller is communicating with the peripheral interfaces. In the middle we can see we have our microcontroller PIC16F877A that is communicating with the LEDs, the light emitting diode, and these are connected to microcontroller by using ports, and the port is an interface between the microcontroller and LED. On the left side we have an EEPROM that stands for electrically erasable programmable read-only memory. On our project we are using the matrix keypad where the tactile switches that are used to thermostat the flow of the current through a circuit are connected in rows and column format. And we are also using a CLCD, which represents the character liquid crystal display used to display all ASCII characters. Data lines of the CLCD are connected to port D. The CLCD we are using for our project is having HD4478016 multiplied with 4 interface. This type of interface, it will print 4 lines, and on each line we can print 16 characters. So that was all about the theoretical part. Further, I'm going to show you a demo presentation. So this is the PIC Lab simulator on which the microwave oven project was deployed. As we can see, it has the PIC16F877A microcontroller integrated in the simulator. In our PIC Lab simulator, we come to know that LEDs are connected to port B and port D. On the left side, we have the matrix keypad that I'm going to use in order to perform specific tasks in the simulation. As mentioned previously, tactile switches are connected in rows and columns format. On the right side at the top, we have the cooler that will start running once we start the microwave oven. The CLCD we are using is this one, and it's having HD44780 interface that will print 4 lines, and on each line we can print 16 characters. Now let me show you how this works. I'm gonna upload the code in order to start the oven. The oven is powering on, and it will be redirected to the menu screen. On the menu screen, we have 4 options. 1 stands for micro mode, 2 for grill mode, 3 for convection mode, and 4 for start. I'm gonna press key number 1 to start the micro mode. It will show the power in 100 watts, and it will be redirected to the screen where we can enter the time in seconds and minutes. I'm gonna enter seconds and minutes. Now we can use the asterisk key if you want to clear the time that was already entered, and press the hashtag key if you want to start the oven. Now we can see that the oven is running, also the cooler is running. Now if you press key number 4, it will increase the time by 30 seconds. As we can see, the time was already increased. If you want to pause the oven, we can press key number 5. And the oven is paused. If you want to start again the oven, we press again key number 4. Now the oven is running again. As it shows on the menu screen, we press key number 6 if you want to stop it. And the oven has stopped. Now let's see option 2, which stands for grill mode. I'm gonna press key number 2 to start the grill mode. And it shows the screen where you can enter second and minutes. We can use the asterisk key if you want to clear the time, and press the hashtag key if you want to start the oven. Now when the time will reach by 0, the oven will time out and the buzzer will make a sound. Here we like this one. Now let's see option number 3. This stands for convection mode. I'm gonna press key number 3. Here we have a screen where we can enter the temperature. I'm gonna enter the temperature. And we can use the asterisk key if you want to clear. And enter a new temperature. And press the hashtag key to start the preheating mode. When the preheating mode will be completed, the screen will be redirected to another screen where you can enter the time. Okay, I'm gonna enter seconds and press the hashtag key. Now we can see that the oven is running. Now if you press key number 4, it will increase the time by 30 seconds. If we press key number 5, it will pause the oven. Now you can see that it's paused. And start again by pressing key number 4. Now you can see that oven is running again, cooler it's running. We have another option, key number 6, if you want to stop the oven. I'm going to press it to see how it works. And as you can see, the oven has stopped. Now let's see option number 4. If we press key number 4, the oven will start directly. As you can see, the oven is running, the cooler is running. And when the time will reach 0, the oven will time out and the buzzer will make a sound. So now let's wait for the time to become 0. And it's timing out. So that's all about for my demo presentation. Thank you for watching. I hope you have enjoyed my presentation.